In this video, we're going to have a look at finding invariant points and also invariant lines. So to start with, I'm going to go through what an invariant point is. So if you apply a matrix transformation to a set of invariant points, then that set of points would just map to itself. That's what it means for a set of points to be invariant. Here we're going to check that if k is equal to 4 and you multiply to a set of coordinates xy, will those coordinates stay matched to xy? That's what we're going to check here. So let's start by replacing k with 4. We're going to have that the matrix becomes 4, 2, 6, and k. Sorry, k with 4. And then we're going to multiply that by a set of points. And we're going to check if that maps to a set of invariant points. So 4 times x is 4x. 2 times y is 2y, and we add that onto 4x. 6 times x is 6x. Plus 4 times y is 4y. And we make that equal to xy. We're now going to match the tops of the matrices and the bottoms of the matrices. So when we match the tops, we get 4x plus 2y is equal to x. And matching the bottoms of the matrices, we get 6x plus 4y is equal to y. Let's now rearrange and make y the subject of both of these equations. Starting with this one, if we subtract 4x from both sides, we get 2y equals minus 3x. And then we can divide both sides by 2, so y is equal to minus 3 over 2x. Here, we can start by subtracting 4y from both sides. So we get minus 3y on the right hand side is equal to 6x. And then we can divide both sides by minus 3 to get y is equal to minus 2x. What we should have gotten is that there's an equation for y in terms of x and they match. Here they don't match. That means that there's no set of invariant points and we write none for option A. Let's now check the same process with option B and check if there isn't a line of invariant points that match. So this time we're going to replace k with 5 and this matrix becomes 4, 2, 6 and 5. If we now apply a set of points x and y and make that equal to x and y, let's see if we get a line of invariant points that match. Again, we're going to multiply the matrices like we did before. 4 times x is 4x plus 2 times y is 2y. 6 times x is 6x plus 5 times y is 5y. And you make all of that equal to xy. Matching up the tops and the bottoms of the matrices again, we get 4x plus 2y is either equal to x, or we get 6x plus 5y is equal to y. Again, we're going to rearrange it for y. We can start by subtracting 4x from both sides again, so we get 2y is equal to minus 3x, and divide both sides by 2 to get y is equal to minus 3 over 2x. Applying that same idea here, we're going to start by subtracting 5y from both sides, so we get minus 4y, because y take away 5y is minus 4y equals 6x. And then we're going to divide both sides by minus 4 to get y is equal to minus 6 over 4x. Now 6 over 4 is just 3 over 2, so I'm going to write this out as minus 3 over 2x. Here we see the equation for y in terms of x matches, and that's what tells you that y equals minus 3 over 2x is a set of invariant points in this instance. Let's now move on to the last question, which is what most students struggle with, finding invariant lines. Here, again, we're going to use the fact that k is equal to 5. So we're going to use 4, 2, 6, and 5 as our transformative matrix. We're going to check if this here is invariant, we're going to choose a random coordinate that's on this line. So when x is equal to t, y would be equal to 2t minus 3. To start with, we're going to multiply the transformative matrix that we introduced this here by t and 2 minus 3. When we do that, we get 4 times t, and then plus 2 lots of all of this. So 2 times 2t is 4t, and 2 times minus 3 is minus 6. I'm going to simplify this just to make it simpler. We end up at 8t minus 6. Now doing that again for the bottom of the matrix this time. 6 times t is 6t, plus 5 times 2t is 10t. 5 times minus 3 is minus 15. 6t plus 10t is 16t, so this becomes 16t minus 15. To finish off this question, we're going to check, by the way, this set of points should also be part of this equation of a straight line. So let's check if that's consistent. We know y is equal to 16t plus 15. We want to check if 2x minus 3 is equal to 16t plus 15 when we put x as 8t minus 6. So let's do that. 2 lots of 8t minus 6, all take away 3, is equal to 16t minus 12 minus 3, which Oh, sorry, I just realized one thing. This should be a minus 15. Sorry about that. And then, yeah, it does end up matching up. It becomes 16t minus 15. So we say that y equals 2x minus 3 is therefore an invariant line of the transformation. Hopefully that makes sense to you guys. Sorry about that mistake that I made a little bit earlier. But yeah, be sure to like the video if it helped and subscribe. I'd appreciate it a lot. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level Furthermaths, be sure to hit my website up at www.excellineducation.co.uk.